Welcome to the premiere episode of The Modern Data Stack Deep Dive. I'm Sonu Singh, and I'm thrilled to kick off this exciting new series where we break down the building blocks of the data world, one layer at a time. In this series, we'll explore the powerful concepts and technologies that are reshaping data engineering. From the rise of big data and cloud-native architectures to tools like Snowflake, dbt, and Airflow, we'll decode how these components fit together in the modern stack. Today, we're stepping back to look at the big picture. What is the modern data stack? Why was it born, and why does it matter, especially in 2025 and beyond? Why are industry leaders building their data infrastructure on the modern data stack? Let's unpack the answer. At its core, the modern data stack is a modular, cloud-native approach to analytics. It moves away from traditional, monolithic enterprise platforms and embraces a flexible ecosystem of off-the-shelf, interoperable tools. Think of it like Lego for data. Each tool performs a specific job and plugs into the broader system seamlessly. Whether it's ingestion, transformation, orchestration, or visualization, every layer is decoupled but deeply integrated. The result? A more agile, scalable, and cost-efficient data architecture? This architecture didn't emerge in a vacuum. The shift began when cloud providers changed the game with scalable, pay-as-you-go infrastructure. Before that, big data tools, like Hadoop and Spark, offered raw power but demanded heavy engineering lift and complex maintenance. Companies found themselves over-engineering solutions for problems that didn't always need such heavy tooling. The modern data stack flips that model. It allows organizations to start small, move fast, and scale on demand. It elevates data engineers from managing servers to designing value-driven pipelines, automating workflows, and ensuring data governance and quality at scale. Why does this matter today? Because this stack has democratized advanced data capabilities. It's not just for tech giants anymore. Companies of all sizes can now build robust, enterprise-grade data infrastructure without a huge budget or an army of engineers. And while tools will evolve, the foundational principles remain timeless: modularity, interoperability, scalability, and simplicity. SQL still reigns supreme. Command line skills still matter, and real-time data is no longer a luxury, it's becoming the standard. Whether you're building internal analytics or AI-powered products, the modern data stack provides the flexibility and velocity required to innovate continuously. Organizations that adopt this stack move faster, stay agile, and unlock the true potential of their data. And that's exactly what we'll explore in the segments ahead. Make sure to like this video, subscribe to the channel, and hit the bell so you don't miss what's coming next. Now, we're diving deep into a critical transformation in the world of data. The shift from the legacy data stack to the modern data stack. This isn't just a technical evolution, it's a complete rethinking of how businesses store, process, and analyze data. Whether you're a data analyst, engineer, or decision maker, understanding this shift is essential. Let's rewind to the early 2000s, the era of the legacy data stack. The traditional model followed the ETL process. Extract, transform, load. Data was pulled from source systems, cleaned and reshaped, then loaded into a centralized data warehouse, typically an on-premise, monolithic solution. Organizations owned and managed their hardware. That meant upfront capital expenditure, buying servers, licensing software, and budgeting for physical storage. Scaling up wasn't just a technical decision, it was a financial commitment, often requiring weeks or months to execute. Systems were tightly coupled, hard to modify, and prone to bottlenecks. Data engineers wrote and maintained fragile custom scripts. Integrating new data sources? That could break the whole system. Then the cloud changed everything. Enter the modern data stack, and with it, a paradigm shift. ELT, extract, load, transform. Now, raw data is loaded directly into scalable cloud platforms. Tools like Snowflake, Redshift, and BigQuery handle transformations on the fly with powerful compute capabilities. What defines the modern data stack? Cloud-native, modular, and scalable components. Think plug-and-play tools, one for ingestion, another for transformation, one for orchestration, and so on. The stack is no longer a monolith, it's a curated ecosystem. The cost model flipped. Instead of massive upfront investments, it's now pay-as-you-go. You scale compute and storage up or down based on usage, aligning costs with actual business needs. This dynamic model supports financial agility and aligns with FinOps best practices. Self-service is a game-changer. Analysts can query data directly. Engineers focus on building infrastructure and managing pipelines, not babysitting servers. The emphasis has shifted to governance, automation, and scalability. Another major shift? Community-driven innovation. Tools like dbt and platforms like Databricks thrive thanks to open-source ecosystems and vibrant user communities. This collaboration accelerates feature development, best practices, and adoption. Let's summarize the key differences. Category: legacy data stack, modern data stack. Architecture: monolithic, tightly coupled, modular, plug-and-play. Processing pattern: ETL. Transform before load, ELT. Transform after load. Infrastructure: on-premises, self-managed, cloud-based, often managed. Cost model: capital expenditure, CapEx. Operational expenditure, OpEx. Engineering focus: system maintenance and integration, data ops, orchestration, governance. Now, even the modern data stack is being pushed further. We're entering the era of real-time data architectures, or what some call the live data stack. This new frontier blends analytics and operations, supporting low latency, streaming-first use cases. Understanding this evolution isn't just about staying current, it's about being strategic. The shift from legacy to modern isn't just about better tech. It's about enabling faster decision-making, scalable growth, and resilient architecture. Are you still working with legacy systems? Or are you leading the way with modern architecture? Drop your thoughts in the comments. I'd love to hear your experiences. And if this video helped clarify the landscape, don't forget to like and subscribe for more insights from Let's Talk About Data. We explored the major shift from the traditional legacy data stack to the modern data stack, and why that transformation was inevitable. With cloud computing redefining scalability and agility, it's time we unpack the anatomy of this new paradigm. Now, let's break down the modern data stack, its key components, how they fit together, and what truly makes it modern. At its core, the modern data stack is designed to convert raw data into actionable insights through modular, cloud-native tools. Unlike the monolithic architecture of the past, today's stack thrives on plug-and-play flexibility and seamless cloud integration. Let's walk through the journey. Data takes in this ecosystem. It starts with data ingestion, the process of bringing data into the system from various sources. Traditionally, data would be extracted, transformed, and then loaded. Today, however, the shift is toward ELT, extract, load, then transform. Why? Because cloud storage is abundant and cost-effective, and transformations can now be executed directly within powerful data platforms. This allows organizations to store raw data first and transform it later based on specific needs, providing both speed and flexibility. Next comes storage and warehousing, where your data resides. Instead of physical servers, today's stack leverages scalable, cloud-based platforms that can grow dynamically with your data needs. The pricing model is consumption-based, meaning you only pay for what you use. This financial efficiency, often managed under a practice called FinOps, allows businesses to optimize both performance and cost. With raw data in place, the next phase is transformation, cleaning, structuring, and enriching your data to make it usable. In modern workflows, transformations are often defined as code using SQL or scripting frameworks. This approach supports version control, testing, documentation, and collaboration, bringing software engineering principles into data engineering. Transformation doesn't exist in a vacuum. That's where orchestration comes in, coordinating tasks and managing dependencies across your data pipeline. Modern orchestration tools use advanced scheduling logic to ensure your workflows run reliably and efficiently, even as complexity scales. Across the entire stack lies a foundation of data management and governance. This encompasses metadata management, data quality, privacy, security, and compliance. A modern stack must ensure trust, accountability, and discoverability. This is where data ops comes into play, fostering collaboration, automation, and continuous improvement in the way data is handled across teams. At the end of the pipeline lies the reason all of this exists: analytics and BI. This is where insights are delivered to stakeholders through dashboards, reports, or interactive tools. The goal? Empower teams across the business with self-service analytics. No more waiting on a data team for every insight. Structured, governed data enables autonomy and speed in decision-making. So what makes the modern data stack truly modern? It's not just the tools, it's the mindset. Cloud-first, code-defined, modular, scalable, and deeply aligned with business agility. But the evolution doesn't stop here. With growing demand for real-time data, the industry is now exploring the live data stack, a next-gen approach focused on streaming, continuous intelligence, and tighter integration with operational systems. Understanding the building blocks of today's data infrastructure is essential for navigating tomorrow's innovations. The modern data stack isn't just a trend, it's a strategic foundation for the future of data-driven organizations. Are you using parts of the modern stack in your workflows? What tools or practices have been game changers for you? Drop your thoughts in the comments. If this gave you clarity, give it a like and hit subscribe for more content like this. So far, we explored the key components of the modern data stack, a modular, cloud-first approach built on tools for ingestion, storage, transformation, and beyond. Now, we're diving into one of the most pivotal evolutions in modern data architecture, the shift from ETL to ELT. This isn't just a change in terminology, it represents a foundational transformation in how data is processed, modeled, and utilized. So, what's the difference? And why did the industry move in this direction? Let's break it down. For decades, the go-to pattern was ETL, extract, transform, load. Data was extracted from source systems, transformed on a separate server, and then loaded into a data warehouse. The transformation step involved cleansing, aggregating, joining, and structuring the data to match business requirements before it ever reached analysts. This sequence made sense back then. Legacy data warehouses weren't built for storing large volumes of raw data or performing heavy-duty transformations. They were role-based, limited in scalability, and optimized for transactional systems, not analytics. So, transforming data beforehand was simply a technical necessity. Then came the cloud, and with it, ELT, extract, load, transform. Now data is extracted and loaded directly into scalable cloud storage or data warehouses like Snowflake, BigQuery, Redshift, or Databricks. Transformations are performed after loading, within the warehouse itself, leveraging its built-in power and flexibility. The driving forces behind this shift? Cloud storage and elastic compute. Cloud storage made it cost-effective to retain massive volumes of raw data. Meanwhile, modern warehouses introduce columnar storage and high-performance compute, specifically optimized for analytics. With this, teams can store raw data first and run complex transformations on demand within the same environment. This shift did more than just improve performance, it redefined team dynamics. In an ELT model, analysts and analytics engineers can work directly with raw data using SQL, removing bottlenecks caused by relying on data engineers for upstream transformation logic. It's created space for new roles, like the analytics engineer, and led to widespread adoption of tools like dbt, which brings version control, testing, and modularization to SQL transformations, applying software engineering principles to analytics workflows. And here's a key advantage. By loading raw data first, teams gain the ability to retransform data in new ways as business needs evolve, without needing to revisit source systems or rebuild pipelines from scratch. That said, not every ELT pipeline is purely raw. A hybrid pattern known as ETLT has emerged. Here, a light transformation step occurs between extraction and loading. This isn't about applying business logic, it's about technical necessities like deduplication, token masking, or schema normalization. It ensures compliance and efficiency, especially in high-volume or sensitive environments. Zooming out to the broader data engineering lifecycle, which includes generation, ingestion, transformation, and serving, ELT primarily influences the ingestion and transformation stages. Orchestration tools like Apache Airflow, Dagster, Prefect, and Databricks workflows coordinate and automate these ELT processes, ensuring consistency, reusability, and observability across the pipeline. As powerful as ELT is, the future may demand even more agility. Real-time analytics, event-driven architectures, and streaming pipelines are driving innovation toward patterns like STL, stream, transform, load. Batch ELT won't disappear, but for real-time applications, the ability to process and transform data on the fly is becoming increasingly critical. So, there you have it. The ELT paradigm shift has transformed not just our data architectures, but how teams collaborate, build, and innovate. It's a foundational element of the modern data stack, and it's shaping the future of analytics. What's your experience with this shift? Still running ETL pipelines? Or have you embraced ELT, or even ETLT? Share your thoughts in the comments. If you found this breakdown helpful, don't forget to hit that like button and subscribe for more forward-thinking data content. We just explored the paradigm shift from traditional ETL to ELT, where data is first loaded into cloud platforms and then transformed, ushering in the era of the modern data stack. Now, let's make that concept tangible with a real-world example. We'll examine how a global retail company modernized its data infrastructure and embraced a cloud-first strategy to overcome legacy limitations. Before modernization, this company faced a familiar challenge. Its enterprise systems updated data only once a week. This meant stakeholders were relying on stale data to make daily business decisions. In addition, generating retail analytics could take upwards of 48 hours, making it nearly impossible to react in real time to evolving market conditions, customer behavior, or inventory needs. Clearly, something had to change. The organization needed faster, fresher, and more reliable access to its data. To tackle this, the company initiated a cloud-first transformation. They transitioned their data architecture to a modern platform capable of handling large-scale ingestion, storage, and real-time transformation. A critical step was enabling continuous data ingestion from enterprise systems. Instead of waiting days, relevant business data now flowed continuously into a centralized data platform, giving near real-time visibility across operations. Once data was ingested, transformations were performed directly within the platform using structured pipelines. This marked the real value of ELT, allowing transformation at scale using the platform's native capabilities. The transformation pipelines followed a layered architecture, often referred to as bronze, silver, and gold layers. Raw data was first ingested, bronze, then cleaned and validated, silver, and finally aggregated and modeled for business consumption, gold. This architecture enabled automation, version control, data quality checks, and reproducibility, significantly improving the team's development velocity and reducing manual rework. The impact was significant. Analytical processes that once took 2 days were now completed daily, an 80 to 90% acceleration in data delivery. Business units gained access to real-time insights, allowing them to optimize strategies based on up-to-date information. With unified, near real-time data, teams could more effectively track performance, understand customer sentiment, and drive innovation. The modernization empowered cross-functional teams to make informed decisions faster. This transformation is a textbook example of how moving to a modern, cloud-native data stack can unlock tremendous value. Shifting from batch to streaming, from rigid ETL to flexible ELT, and from siloed systems to integrated platforms, enables organizations to operate with agility and precision. The future of data is real-time, scalable, and intelligent, and this retail company proved it's not just a vision, but an achievable reality. What's your modernization story? Share your thoughts in the comments below. If you found this deep dive valuable, give it a like and subscribe for more content on data strategy and innovation. Now, we're diving into a critical topic for enterprises navigating the future of data: why the modern data stack matters. Many enterprises still rely on legacy data architectures built decades ago. These monolithic systems, think massive enterprise, data warehouses, or early data lakes, were designed to centralize control. But over time, they've evolved into tangled webs of dependencies that are difficult to change without breaking something else. This centralization creates a major problem: lack of agility. Data latency becomes a bottleneck, preventing timely decision-making. In a world where speed defines success, stale data and delayed insights can cost you more than just time, they cost competitive edge. Compounding this is the rapidly changing data landscape. Cloud-native platforms, microservices, SaaS applications, and exploding data volumes are fragmenting the data ecosystem. Traditional systems can't scale effectively in this new environment. A shift is not only necessary, it's inevitable. That brings us to the solution: the modern data stack. The modern data stack is a cloud-native, modular, plug-and-play set of tools designed to handle data ingestion, storage, transformation, analytics, governance, and visualization seamlessly. Unlike legacy systems, it offers flexibility, scalability, and accessibility. A cornerstone of this architecture is the shift from ETL to ELT. Raw data is loaded directly into scalable cloud data platforms, and transformations happen later, on demand and in powerful environments. This reimagines how we manage the data lifecycle, making it faster and more cost-effective. So, why does this matter for large enterprises? 1. Scalability and flexibility. Cloud-native infrastructure enables near-infinite scale and global availability. Enterprises can scale data systems to match growth, adopt pay-as-you-go models, and avoid vendor lock-in. This modularity supports faster experimentation and more resilient architecture. 2. Faster insights and real-time capabilities. The modern data stack allows real-time and near-real-time data flows. Businesses can move from asking what happened to what's happening now. This accelerates analytics, drives operational intelligence, and powers proactive decision-making. 3. Modularity and decoupling. Plug-and-play components reduce system complexity and eliminate big ball-of-mud architectures. Each component can evolve independently, lowering risk and enabling rapid innovation. 4. Empowering teams with self-service. No more waiting on central IT. The modern data stack puts power into the hands of analysts, engineers, and data scientists. Teams can build pipelines, explore data, and generate insights independently. 5. Enhanced data governance and management. As data volumes and regulations grow, so does the need for trust and transparency. The modern data stack integrates governance, quality checks, metadata management, and lineage tracking, ensuring accuracy and compliance at scale. Ultimately, the modern data stack matters because it's not just an upgrade, it's a transformation. It equips organizations with the agility, speed, and control required to operate in a data-centric world. It empowers teams, reduces friction, and aligns technology with strategic business outcomes. And while the stack itself continues to evolve, with new focus areas like real-time streaming and live data pipelines, its core principles remain: cloud-first, modular, decentralized, and empowering. So, let me ask you this: What data challenges are you tackling in your organization? Have you made strides toward modernizing your stack? Drop your thoughts in the comments, and if this video sparked ideas or gave you clarity, hit that like button and subscribe for more insights into the evolving data landscape. In our last session, we unpacked the promise of the modern data stack: scalability, agility, and democratization of data. But as with any transformation, there's another side to the coin. Now, we're diving into the criticisms and trade-offs enterprises face when adopting the modern data stack, so you can make strategic, future-proof decisions with eyes wide open. The modern data stack, a collection of cloud-native, plug-and-play components, aims to simplify enterprise data platforms. But underneath this modular design lies an evolving paradigm that, while technologically fresh, often repackages long-standing data warehouse practices. And that distinction matters. While the tooling is modern and agile, it's still rooted in traditional paradigms that were never built for today's real-time, data-intensive demands. Let's walk through the critical challenges and trade-offs that enterprise leaders must consider. 1. Complexity isn't eliminated, it's reallocated. The modularity of the modern data stack shifts complexity from monolithic systems to orchestration between dozens of tools. Integration, interoperability, data lineage, and consistent governance across this fragmented stack remain a formidable challenge. Without intelligent self-service, metadata management, and standardized data cataloging, organizations risk recreating the chaos of old, just with newer tools. 2. Cost management requires operational discipline. The cloud's pay-as-you-go model is a double-edged sword. It offers flexibility, but without rigorous FinOps practices, it quickly spirals into inefficiency. On-demand pricing, data egress charges, and redundant storage or computation layers can silently erode budgets. Reserved capacity and usage-based optimization are essential, and in some scenarios, self-hosted or hybrid deployments might prove more economical at scale. 3. Tool volatility and the risk of trend chasing. The modern data stack is caught in a cycle of constant innovation. Tools rise fast and fade faster. The danger? Adopting technologies based on hype rather than long-term value. Enterprises must be prepared to evaluate their stack every few years, and most importantly, ensure that every tool can be replaced without architectural lock-in. Flexibility must be designed into the system from day one. 4. Real-time isn't the default, it's a commitment. Real-time data processing sounds ideal, but it brings complexity, latency trade-offs, and infrastructure overhead. While batch processing remains a dependable workhorse for many use cases, real-time should only be implemented where latency directly affects business outcomes. Attempting to blend both often leads to architectural headaches and increased operational costs unless done with precision and purpose. 5. Transformation still requires engineering rigor. ELT enables flexibility, but designing transformations, especially across varied historical datasets, demands strong orchestration, version control, and performance tuning. Building reusable, modular transformation logic is non-trivial and requires disciplined engineering. And as semantic layers grow, so does the risk of adding unnecessary abstraction and performance overhead for simple analytics needs. 6. Governance and trust demand active stewardship. Modern tooling supports governance, but governance itself is not automated. Traceability, versioning, and compliance with regulations like GDPR and CCPA must be intentionally engineered into your pipelines. Data quality monitoring, automated testing, and user trust must be embedded into your culture. One silent failure in trust, and the entire stack risks being sidelined. So, what's the verdict? The modern data stack isn't a silver bullet. It's a flexible, powerful architecture that must be approached with strategic rigor. The key lies in making reversible decisions, avoiding tool lock-in, and aligning your technology investments with actual business outcomes, not market hype. Embrace modularity, but don't lose sight of governance, operational costs, and the true complexity of integration at scale. Have you faced any of these challenges in your organization? Drop your experiences in the comments. Let's open the floor to candid conversation. If this helped you think more critically about your data strategy, hit like, and don't forget to subscribe for more deep dives into enterprise data architecture. We've explored the factors driving its rise: cloud adoption, microservices, and evolving software delivery models, all of which have changed the data landscape dramatically. The MDS is about agility, scalability, and enabling organizations to better respond to the complexities of modern data management. It draws heavily from architectural principles like modularity and domain-driven design, setting a foundation that's more flexible and accessible than ever before. We also didn't shy away from the hard truths. The modern data stack isn't a silver bullet. It introduces new challenges: tool fragmentation, increased complexity and integration, cost management concerns, and the need for robust governance and quality assurance. So, why is the MDS so important, and what should we carry forward from our exploration? The modern data stack isn't just a buzzword, it's a new approach to managing and scaling data capabilities. It democratizes access to powerful tooling, lowers the barrier to entry, and empowers data analysts, engineers, and decision-makers. It represents a critical step in helping organizations truly become data-driven. Let's break down the three biggest takeaways from this segment. 1. The modern data stack is modular, cloud-native, and scalable by design. Rather than using massive, expensive monoliths, the MDS focuses on plug-and-play components that are easy to integrate, use, and scale. Think cloud data warehouses, object storage, and API-first tools. This composable approach allows teams to move fast, work in parallel, and adjust the stack to their evolving needs. It reflects the shift from centralized control to federated models of data ownership. Scalability isn't just an outcome, it's a design principle that shapes how we build modern data platforms. ELT and tools like dbt are at the heart of modern data pipelines. The transition from traditional ETL to ELT has fundamentally changed how organizations handle data preparation. With cloud storage and processing power, teams now load raw data first, then transform it for analysis using tools like dbt. This shift not only simplifies architecture, but also enables faster iteration and better collaboration between analysts and engineers. Transformation is no longer a back-end process. It's where the real value is created, turning data into insights. 3. The modern data stack laid the foundation, but it's not the final evolution. By simplifying analytics and enabling self-service, the MDS unlocked the next generation of business intelligence and machine learning. But data demands are evolving. The future is moving toward real-time analytics, tighter application data integration, and live data systems. We're beginning to see architectures emerge that go beyond batch pipelines and cloud data warehouses, towards event-driven, streaming-first platforms that power operational workflows as well as analytical insights. Understanding the modern data stack, what it solves, what it simplifies, and what it challenges, is fundamental for anyone working in today's data-driven world. It's not just a set of tools, it's a mindset shift in how we build for agility, scale, and impact. But this is just the beginning. In the episodes ahead, we'll dig into the building blocks of modern data architecture in more detail: cloud data warehouses, data products, governance, and metadata management, data ops, orchestration, streaming, and much more. This series is built for you, the data practitioners, the builders, the curious minds shaping the future. If today's recap brought clarity or sparked ideas, subscribe to the channel so you don't miss the upcoming deep dives. Join the conversation on LinkedIn, the link's in the description. Share your thoughts, stories, or questions about working with the MDS. Like and share this video to help others in their data journey. Thanks for joining me on this journey. Understanding the foundation is the first step toward mastering what comes next. Let's talk about data and how we build its future.